Let's learn today division of polynomials. Here I have a question. Here I have to divide this polynomial px by the polynomial gx. Before starting the division, we should remember that the polynomials should be in descending order of their powers. Here px is equal to, the highest power here is, look at this polynomial px. The highest power here is 3x square. So 3x square, then plus x, and then minus 1. And what about gx, about my divisor? Again, this is not in decreasing powers. So first it will be x, then plus 1. Now let's start dividing. 3x square plus x minus 1, x plus 1. First of all, we are going to look at the first term in dividend as well as the divisor. My first term here is 3x square, and I am going to divide it by the first term of the divisor. So it is 3x. So the first term of the quotient will be 3x. Now the whole divisor, all the terms of the divisor will get multiplied with the quotient. So first x will get multiplied with the quotient. So x into 3x will be 3x square. And we are going to write like under like. And 1 into 3x will be plus 3x. So it will be written under the x term. Always write like under like. Change the signs in the second row. My first term is getting cancelled. Now we are going to consider the new signs here. X minus 3x. X minus 3x will be minus 2x. And bring down the remaining terms here. Now my new term, the new first term is minus 2x. So I am going to divide minus 2x with the first term of the divisor. So minus 2x upon x is minus 2. So the second term of the quotient is minus 2. Now again the whole divisor, all the terms in the divisor will get multiplied with minus 2. So first of all x will get multiplied with minus 2. So it will be minus 2x. Then 1 will get multiplied with minus 2. It will be minus 2. Change the signs in the second row. So what is my remainder here? The remainder is minus 1 plus 2, it is 1. This is my remainder. Now in division of polynomials, when will we stop the division? When will the division stop? Whenever the degree of the remainder. Here, what is the degree of this remainder? The degree is equal to 0 because it's a constant. And what is the degree of a constant? The degree of a constant is 0. And what is the degree of this divisor? The degree of this divisor is 1. When will the division stop? The division stops when degree of remainder is less than the degree of divisor. Let's take one more example of division. I have to divide 3x4 minus 4x cube minus 3x minus 1 by x minus 1. Now both the polynomials are in descending order of their power. So I need not do any changes here. So let's start dividing. 3x to the power 4 minus 4x cube minus 3x minus 1. This has to be divided by x minus 1. So first of all, I'm going to look at first term of both the dividend and the divisor. So I will get my first term of the coefficient. So 3x4 will get divided by x. That means the first term of the quotient is 3x cube. So now the whole divisor will get multiplied with this term. So first of all, x will get multiplied. So it will be 3x to the power 4. Now minus 1 will get multiplied. So minus 1 into 3x cube is minus 3x cube. Change the signs in the second row. Minus 4 plus 3 is minus x cube. Bring down the remaining terms. Now again look at the first term at this step and the first term of my divisor. It is minus x cube upon x. So it is minus x square. So the second term of my coefficient is minus x square. Now again the whole divisor will get multiplied with minus x square. So first of all x will go and get multiplied with minus x square. So it will be x into minus x square minus x cube. Then Minus 1 will go get multiplied with this. So minus 1 into minus x square is positive x square. But look here, I don't have the x square term. So I will write it separately here. If you don't have any term which is like to that, you can write it separately. Now change the signs of the second row. Now, I'm not going to write minus 3x first. I'm going to write the highest power first. My highest power is square here. So, minus x square will be written first, then minus 3x and minus 1. Keep it in mind that at every step, the powers should be in descending orders. Now, again, look at the first term of this step and the first term of the divisor. It will be minus x square upon x. So, it is minus x. So, the new term of the coefficient is minus x. Again, the whole divisor will get multiplied with, so first of all x will go get multiplied with minus x, it is minus x square, then minus 1 will go and get multiplied with minus x, so it is plus x. Remember to write like under like. So now it is minus 3x minus x minus 4x and the remaining terms minus 1 coming down. Again, look at the first term of this step now. So it is minus 4x will be divided by x. So minus 4x upon x is minus 4. So what is the next term in the coefficient? It is minus 4. Now again, x will get multiplied with minus 4 first. So it will be minus 4x and then minus 1 with minus 4 plus 4. So minus 4x plus 4. Minus 4x plus 4. Change the signs. Minus 5. Now here what is the degree? Here the degree is 0. But what is the degree of my divisor? The degree here is 1. Now my degree of divisor is greater than the degree of remainder. That means in simple language, the degree of the remainder is less than the degree of the divisor. So my division will stop here. So my remainder is minus 5 and my quotient is 3x cube minus x square minus x minus 4. So in this manner, we divide the two polynomials. Now let's come to remainder theorem. The remainder theorem says, let px be any polynomial of degree greater than or equal to 1 and let a be any real number. If px is divided by linear polynomial x minus a, then the remainder is p of a. Let's try to understand it in simple language. It's saying that suppose I have a polynomial px which is being divided by a linear polynomial x minus a. The degree of this polynomial should be greater than or equal to 1. It cannot be a constant. If the degree is less than 1, that means the degree is 0. And if the degree is 0, it means it should be a constant. So it should not be a constant. It should not be a constant. It should not be any number. It should be a polynomial in terms of x and the minimum degree should be 1. And if I am dividing it by another linear polynomial, what do you mean by a linear polynomial? Whose degree is 1. So the outside divisor should be a linear polynomial only. This has to be a linear polynomial. The inside dividend can be linear, quadratic, cubic, anything. Anything one or more than one. So it is saying that if I divide any polynomial px by a linear polynomial x minus a, then my remainder is p of a. Remainder is p of a. So how to calculate this p of a? Actually, my divisor is x minus a. And we all have learned to find the zero of the polynomial. How do we find the zero of a polynomial? We put it equal to 0. So if I try to find the zero of divisor, what is the zero of divisor here? If I put it equal to x minus a equal to 0, so my zero is a. So what is going to happen? I am going to put this zero, put the zero of divisor in the polynomial. Let us try to understand with the help of some examples. So let us take this example, which I have already done with you while doing division. Okay. Now I have my polynomial px, this thing, and this is my dividend, and this is my divisor. What did I tell you? That we have to find the zero of the divisor. Try to find the zero of the divisor. So zero of the divisor, what will be the zero of the divisor? I will put it equal to 0. So x is minus 1. So what am I going to do? I am going to put this number in the polynomial. So therefore, so by remainder theorem, the remainder is equal to p of a. That means p of minus 1 here. Just take out the zero of the divisor and put it in the polynomial. So it will be, what is my polynomial actually? My polynomial is, see, I'm marking it with the yellow color here. This is my polynomial actually, px. So instead of x everywhere, I'm going to put it minus 1. So minus 1 plus 3 minus 1 square minus 1. So it is minus 1 plus 3 minus 1. So your answer is 3 minus 2 equal to 1. So you can see here that I will show you that we did the same division and the remainder was 1. Can you see here? The remainder is 1. But instead of doing the whole division now, I can directly find out the remainder with the help of this method. Just find out the zero of the divisor and put it in the polynomial. Let us take one more example. Let me show you the another example that we did. This was the example we did of division and the remainder was minus 5. Now let us check that can we get minus 5 with this method? This is the same question and I'm going to find out the remainder with this new method of remainder theorem. Now what is my divisor here? My divisor is x minus 1. So 0 of x minus 1. So first let's take out the 0 of x minus 1. कैसे निकालते हैं 0? We put it equal to 0. So what is x equal to? X is equal to 1. Now this 0, we are going to put it in px. Who is my px here? This is my px. This is my polynomial. This is my dividend. So therefore remainder is equal to p of 1. जो भी आपका 0 निकल के आएगा वही आपको उस डिविडेंड में डालना है. So my remainder is p of 1. So it will be 3, 1 to the power 4, minus 4, 1 to the power 3, minus 3, 1, 1. So it is 3 minus 4, minus 3, minus 1. 3 and 3 getting cancelled. My answer is minus 5. Can you see? I got the same remainder using a different method of remainder theorem. Now let's come to factor theorem. The factor theorem says if px is a polynomial of degree n greater than equal to 1 and a is any number, then x minus a is a factor of px if p of a is 0 and p of a is 0 if x minus a is a factor of px. Do you think that this statement is approximately same as remainder theorem? It says the same thing, that if I have a px whose degree is greater than equal to 1 and a is any real number. So x minus a is a factor of px if my p of a is 0. Now in a remainder theorem, I told you that if I am dividing a polynomial px by x minus a, the remainder was p of a. Now according to factor theorem, it says that the remainder should be 0. Why so? Suppose I take any number. I take 35 and I know one of its factor is 7. So if I divide it with that, what is my remainder? My remainder is 0. So whenever you have a factor of any number, you divide a number by a factor of it, then you always get the remainder to be 0. So it's saying that this divisor will be a factor only when this remainder is 0. So it's saying if this is a factor, suppose I am dividing this polynomial by a factor, then the remainder has to be 0. And the other way is also true, that if I divide any two things and the remainder is coming out to be 0, then obviously this divisor is a factor of that polynomial. Now let's do this example. Check if gx is a factor of px. So basically I have to check that it's a factor. That means I have to check that P of A is 0. And who is A? A is basically the 0 of the divisor. Who is my divisor here? My divisor is gx. So I need to find the 0 of gx. So 0 of x plus 1. So in order to find the 0 of x plus 1, I will put it equal to 0. So my x is minus 1. Now what I have to do? I have to put this value of minus 1 px. So therefore my remainder, so basically remainder actually means my p of minus 1, my p of a. So it is equal to, let me put the values in this px. So it is 2 minus 1 cube plus minus 1 square minus 2 minus 1 minus 1. So it is minus 2 plus 1 plus 2 minus 1. So it's giving me answer as 0. So yes, gx is a factor of px because my remainder is 0. So mainly we have to see that the remainder should be 0.